Welcome. Today I want to talk about using Apache Kafka with Go. So what is Apache Kafka? It's an open source distributed event streaming system. Distributed means it is very scalable. It can run on more than one machine, and typically you have clusters of 3, 5 or 7 nodes. Each node is called a broker. An event is something that matters to the organization, like for example, customer signed up or invoice paid. And streaming just means it's a continuous flow of data, in this case events. Apache Kafka is written in Java, and because it is a distributed system, you need some mechanism to keep the state of the distributed system consistent, and it uses Zookeeper to do that. Apache Kafka is modeled using publish and subscribe communications model. So clients that connect to the Kafka cluster, these are called clients. They can publish events to the Kafka cluster, and many other clients, or even the same client, can subscribe to these events. All these events are saved on disk in the Kafka cluster, and these events can automatically be cleaned out or purged based on time or size parameters. For example, let's keep a maximum of 100 megabytes per topic, which we'll talk about later, or for 1 year. Some people keep their events for a very long time, 10 years or more. This presentation will have code. If you want to have the code to follow along, you can download it from my GitHub account there. So let's first look at a Kafka subscriber. Kafka calls these clients consumers, and this particular consumer is written in Go. So the first thing we do is we create a consumer. Consumer is a function I wrote. I will show that to you in a while. But the configuration is important, and in order not to clutter up this slide, I wrote a function. A consumer subscribes to a topic, and in this case I am using a free Kafka instance sponsored by Cloud Kafka. Thanks to these people. That's my user ID prefix, and this is the topic that I will subscribe to if I've not already configured it in my environment. So as you can see, with that consumer, I can subscribe using that consumer to a topic. I can read from that consumer and I get a message, and I can print the contents of that message. Now let's look at the consumer configuration. As I mentioned, Kafka is a distributed system, and although this line is truncated, there are actually 3 brokers here. That's the cloudkafka.com, port 1994, and there are 3 of these entries. We'll talk a lot more about group ID later, but essentially consumers work in a group or in a team called a group or consumer group, and there are various parameters on how to deal with topics and how to have a secure communication with the Kafka brokers. So let's look at topics. I've pre-configured 2 topics. You have to configure topics in Kafka. The first one is called tests. It's got 3 partitions. I'll talk about partitions and replicas later, but essentially for tests we will retain a maximum of 1 megabyte and 28 days, while for the topic there's only 1 partition, and we'll also retain it for 28 days. Now let's look at a Kafka publisher. In Kafka lingo or terminology, it's named a producer. So we create a producer from the configuration. We have to give it a channel of Kafka events. I'll explain channel in a while, but essentially a publisher publishes to a topic, and we have to receive feedback on whether the publish is effective, whether it's acknowledged or not acknowledged on the channel. Publish time and print delivery message are go routines, and if I don't have this select, it would fall through and main would terminate. So that's why I have this select or wait forever, empty select or wait forever. So here's the publish time producer. As you can see, it's a go routine. It runs forever, and all it does is it publishes or produces that topic. Essentially just prints the time every 100 millisecond, or prints the time 10 times a second. That's the other way of thinking of it. And print delivery message is the feedback channel. As I mentioned, Kafka is a distributed system. It's designed for very high throughput applications. It was invented, designed, created in LinkedIn. It's a cloud scale, internet scale company. Therefore, it requires very high throughput. So therefore, events are published without waiting for acknowledgements from the Kafka cluster. So how are acknowledgements or non-acknowledgements received? They are received through the client's Go channel. So that's the client's Go channel, and the message is received and it prints out the message. Let's first do a demonstration run. I've actually run it already with a topic with a single partition, and that would be the TER topic. So I need to provide my password. I'm not going to show you my password, and I'm going to use the topic TER, and I'm going to run one subscriber and one publisher. Let me show that to you. It's on this window. So this is the publisher. I've already published 822 events, but actually you can see the event channel working. Offset 822 has already been received by the subscriber, and actually it has actually published up to 828 events, but I have not received the acknowledgement before I interrupted the publisher or the producer. Now, one thing I want to show you here is note the milliseconds, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. It is published roughly every 100 milliseconds, and none of the messages are dropped. So this shows that Kafka is a very high throughput system, one publisher into one subscriber. Let's go back to our slides. So now let's talk about partitions and replicas. Partitions split the event stream into substreams, and each substream is known as a partition. These partitions can be fed into a consumer. Let's say we have three partitions, P1, P2, P3, and two consumers. So P1 and P3 may be fed into consumer 1, C1, and say P2 is fed, the remaining partition is fed into C2. Now C1 and C2 work together as a team. Kafka calls this team a consumer group. When I first read the documentation, I was a bit confused. If I have three partitions, am I limited to a maximum of 3 consumers? No. Multiple consumer groups can consume a single topic. Multiple consumer groups can subscribe to a single topic. So for example, C1, C2 is in one group. I can have a different D1, D2, and D3 in a different group, also subscribing to the same topic. Replicas, on the other hand, is a data protection feature. It allows copies of events to be made across partitions. Aside from it being a data protection feature, it also is a scalability scalability feature, because subscribers can read from whatever read replica that's available. So as I mentioned, Kafka is distributed, typically 3 brokers or 3 nodes. If one of the nodes fail, you have replicas and there's data protection. Let's demonstrate the situation where we have 3 partitions and 2 consumers working in a group. And this is the case where the topic is tests. I've got 3 partitions and I will have 2 consumers. So let me show you the run. That's here. So these 2 are consumers and I've already published, and it's at offset 910. Actually it's already at offset 911, but I interrupted and that message never got through. But notice these numbers here are partition 0, partition 2 and partition 1. So there are 3 partitions here. The subscribers are partition 0, partition 1, partition 0, partition 1, and this particular subscriber only gets partition 2. So as I mentioned, the event stream is divided into 3 substreams. Each of them is called a partition. This particular subscriber, consumer, is allocated partitions 0 and 1, while this consumer is allocated partition 2. So how do consumers identify them as belonging to a team? It's through their group ID. I'll show you the configuration again. Here's the configuration. It's a config map. That's the metadata brokers list. As I mentioned, there are 3 brokers in my test account. This is the group ID. So I configure it in the environment, and this particular group ID is called ABC or 123 or whatever you want to name it. If you have consumers sharing the same group ID, they work in the same consumer group or the same team, if you like. And there are various parameters to tell you whether the consumer should start reading from the earliest event or the latest event or somewhere in between. And these are just security configuration to allow you to connect securely to the Kafka broker. So what happens when you have more consumers in a consumer group than partitions? Perhaps a topic has only 1 partition and 2 consumers working in group A. Call it CA1 and CA2. And you have only 1 consumer, CB1, working in group B. So if P1 talks to CA2, this means CA1 does not receive events at all. CA1 is starved. However, it does not block CB1 from receiving events from the partition, the sole partition. As usual, if you want to download the presentation source code and the sample code samples itself, here is my GitHub repository. Thank you for listening. I work for Zendit.